Hi and welcome everyone. Welcome to Move Physics Quickly channel. Today I have a very important question, very basic question about specific heat, one of the most important titles in physics and medicine. I hope all of you read the question well to get the keywords, to know what's required to be answered, and to solve it easily, inshallah. The question is, we have an aluminum pan of mass of 0.5 kilogram. This pan is on a stove used to heat 0.25 liters of water from initial temperature of 20 degrees to 80 degrees. The question is, how much heat is required to heat the water? The second, how much heat is required to heat the pan? Two questions here. Let's get the keywords and the givens here in this table. This table will summarize everything, and we have very important notes. I hope if you please read it carefully to get more and more experience in how to solve this type of question. The first is, it is given directly the mass of the pan that was 0.5 kilogram. This is the aluminum pan, and its mass is 0.5 kilogram. The volume of the water is given as quarter liter, 0.25 liter. It's given directly here, 0.25 liters. In this question, I'm going to convert the volume of the water from liter units to meter cubic units. And I'll tell you why at the end of this slide. And you have to know that in order to convert from liter to meter cubic, just multiply the liters times 10 to the power -3. I wrote the information here. To convert from liter to meter cubic, we have to multiply liters times 10 to the power -3. So first of all, I converted volume from liter units to meter cubic units by multiply times 10 power -3, and soon you'll be informed why did I convert from this unit to this unit. Then you are given the mass of the water. No, we are not given the mass of the water. Do we need to get the mass of the water? Yes, we need to get the mass of the water. Do you know why? Right, because the question will be answered using a formula states that mc delta T. We are going to discuss everything soon, but we have to get the mass of the water because we need it in our formula that we are going to use. The mass of the water could be obtained from a very simple rule. Guys, do you remember that rho, which is the density of anything, is equal to the mass of the object divided its volume? Very simple equation. From this equation, we can get m by multiplying rho times v, so that the mass of the water equal its density times its volume. And it's clear to all of us that the density of the water is 1000 kilogram per meter cubic times the volume, the one that I obtained here, so that the mass of the water is 0.25 kilogram. This is one of the options that we can do in order to get the mass. Otherwise, we can use the volume directly as mass. I mean, we can use this value as the mass of the water directly. Why? Because in order of using water or blood, the density is almost 1000 kilogram per meter cubic. And when we multiply 1000 times this value, it will be the same as the volume. Again, we have two options here to get m. We can use the volume of the water or the volume of the blood directly as it is as the mass. I mean, the mass of the water equals the volume directly without any conversion, 0.25. Or we can calculate it for other liquids or other fluids. in case of something else than blood or than water, we have to convert. But I converted here just to make you sure that you can do it alone. So the two options are, we can multiply the density of the liquid times the volume to get the mass, or to use the volume as a mass directly. We are also given the change in temperature, delta T. Delta T is T final minus T initial, and here we have the T final 80 and T initial is 20 degrees Celsius. The water is warmed or heated from 20 to 80. So this is the final temperature and this is the initial temperature. Again, guys, we have the mass of the aluminum pan. We have the volume of water, and we also can consider it the mass of water because it's water or blood. Otherwise, we cannot use this rule. Otherwise, we can calculate the mass using the density times the volume. You get it, guys? Very simple. Change in temperature is here, and the specific here for both water and aluminum are given in standard tables. You'll be given it in the exam, in the constants or in the formula sheet. And here the specific heat of water is 1 kilocalorie per kilogram degrees, and the specific heat of, here is something wrong, this one is for aluminum, and the specific heat for aluminum is 0.22 kilocalories per kilogram. And this is information what we got from here. We converted the volume from liter to kilogram because the density that we used here is in unit of kilogram per meter cubic. So that we have to convert liters to meter cubic to match the units. Always, guys, don't forget this, always unify your units. You get the point? I mean, it is impossible to use rho in kilogram per meter cubic times V in liter. No, this one kilogram per meter cubic, so that this one should be in meter cubic to cancel meter cubic with meter cubic, and kilogram stays as unit for the mass. Get it? Let's give a look back at the question again. You are given the mass of the pan. You are given the change in temperature to clear information. And they are recorded here. The mass of the pan and the volume of the water. And two constants. This is the specific heat of water, the specific heat of aluminum. Guys, this one is CAL, not CW. This is typo error. This CW specific heat of water is 1 kilocalorie per kilogram degrees, and the specific heat of aluminum is 0.22 kilocalories per degree. Both will be given to you. The change in temperature is given. The only thing that you are not given directly is the mass of the water. And we told you that you can do it by two options. You may use the volume of the water directly as the mass of water, right here, right? The mass is 0.25, or for other liquids rather than water and blood, you can calculate it using the formula rho times V, and V should be in meter cubic. Rho is the density of the liquid. For this scenario, rho is 1000, and the volume of water I have calculated here as 0.00025. Now, guys, everything is known. The first part of the question is how much heat is required to heat the water. It's very simple now to put the equation Q equals mc delta T, sometimes called delta theta. M is the mass of the water because we are talking about water. C, specific heat of water. Delta T is the change in temperature of water. Guys, look at here. The change in temperature is 60. For what object? For water or for the pan, the aluminum pan? Think about it. Both water and pan are together, always together. Therefore, water and pan are always in contact, so that the change of temperature for water or for pan is the same. I mean, water will be raised from 20 to 80, therefore the pan will be raised up from 20 to 80. And any change appears on the pan will appear on the water, and vice versa. As long as these two objects are in contact, they always have the same changes. Is it clear? So that in this question, delta T is 60 degrees for both, for water and for the aluminum pan. Now, the formula is the same for both. Here you are asked to get the heat required to the water, and here the heat required to raise up the temperature of the pan. The equation is fixed for both. Q in general equals MC delta T. Here Q is MC delta T. The difference is this is M for water and M for aluminum. C for water, C for aluminum. Delta T for water, delta T for aluminum, and both are the same. That's why I didn't write any subscribe beside them. So the Q, which is the amount of heat required to heat the water, is the mass of the water, which is 0.25. You remember? It was here. We calculated. We said that we can use this one or the volume directly. And CW, specific heat of water, which is 1. It's here in the table. 1 kilocalorie per kilogram degrees. And delta T, that was 60 degrees. Now, when you multiply 0.25 kilogram, listen to me carefully, kilogram and 1 kilocalorie per kilogram degree times 60 degree. If you have a pencil and you cancel out the similar units, you'll find degree will be cancelled with degree and kilogram will be cancelled with the kilogram here, and the unit that remains will be kilocalorie. Please, everyone, don't forget that Q always measured in kilocalorie or in joules. When I put joule, you put joule when you are given C in joules. When I put kilocalorie, when C is in kilocalorie. I mean, as you are informed in the question, use the unit here. You see, kilocalorie, so the unit should be kilocalorie. If C is written in joule per kilogram, your unit will be joule here. Fine. So that now the amount of heat used to raise up the temperature of water from 20 to 60 is 15 kilocalorie. This is the amount of heat used to raise up water. Here is the amount of heat used to raise up the temperature of the aluminum pan, the metal. The same is here. Here is the mass, but the mass of the aluminum, 0.5 kilogram. The specific heat of aluminum, 0.22. The change in temperature, 60, which is the same. By multiplying all of these values, we can find it 6.6 kilocalorie. I'd like to stress and highlight something here, guys. You see, the amount of energy needed to raise up the temperature of water is 15 kilocalorie. The amount of heat needed to raise up the temperature of the aluminum is, although the mass of the aluminum is greater than the mass of water, I mean, this one is much heavy than water. It's 6.6. This one is almost double this value. This means the amount of heat required to raise up the temperature of liquids is mainly greater than the amount of heat used to raise up the metals. Do you know why, guys? Who can tell me why? I can listen all of you now thinking about. It's a specific heat, guys. And here you can understand clearly what is the meaning of specific heat. Specific heat is the amount of heat needed to raise up the temperature of an object 1 degree. So we need more temperature to heat water, because let's imagine an example. If you have some water, you want to raise up their temperature and you put it on the stove. It takes a time to be boiled, but when you put a metal on the stove, it will be heated directly and the temperature appears on it directly. So that the amount of heat gained is lesser than the amount of heat given to the water. Thank you, everyone. Wait for more questions. And please don't forget to subscribe the channel. Thank you.